All right, so this has been an exciting ride so far. We're on to the third and final way of solving linear systems, and that's by using elimination. So today we're going to talk about elimination. That is the third and final way. And so now you'll have a whole toolbox of ways that you can solve these linear systems. So thinking about the ways that we've discussed linear systems so far, which way has seemed easier? Is one easier than the others depending on the equations that you have? Think about this for about 30 seconds. I'm not going to actually wait 30 seconds. Press pause. Think about it. And now we can talk about it. Okay, so there were a lot of them that it would have been a lot easier for me to use substitution than graphing, right? That one that we had that word problem in that first day's lesson, that word problem had huge numbers, right? It's not easy to graph huge graphs with large numbers. And so in problems like that, substitution could have come in handy where we could find what that number was. Remember, it went off my graph in that lesson. We could have easier found that method with substitution. Graphing comes easier if we just have really simple equations. It can be easier to really understand what we're doing by graphing. Well, in substitution, so probably I always lean a little bit more towards substitution than graphing. Everyone has their own choice, though. I know somebody else who's all about graphing, but if we have this toolbox so far, and so we always said we want one of the variables for substitution to have a coefficient of 1 or -1. That's what makes it easier. Well, let's be honest. In the real world, our equations don't always look like that. And so elimination is going to come in handy when our equations don't have a coefficient of 1 in front of either of the variables. No equation, no coefficient 1. No equation with the coefficient 1. So in that case, this method of elimination will come in handy. So, like usual, we're going to talk about what elimination is, and then we're going to do a couple examples. If this gets a little confusing, bear with me. You know I'm going to go over some examples. So, our goal in elimination is exactly what it says. We want to add or subtract so that one of the variables goes away or is eliminated. So, we're going to actually add or subtract the whole equation together. It's kind of fun, really exciting. And the goal is to make one of the variables go away. So our steps to doing so are to write the equation so that the variables line up. The variables are in the same place for all of them. Then we are going to add or subtract the equation so that one of the variables is eliminated. We'll solve this new equation that I got from adding or subtracting for the remaining variable. And then we'll use that value to substitute in to find the eliminated variable. I know that gets a little confusing. You don't necessarily know what all I'm talking about. But let me show you some examples and it might make more sense. Don't forget I don't have it written on here. But you should always then go back, even if it's just a mental check, but check your answer. There is no point in giving me an answer that doesn't work for both of them. You can check it. You know whether the answer is correct. You can guarantee yourself a 100. Okay? So let's try some of these. We have 2x plus 3y equals 11. And we have negative 2x plus 5y equals 13. Sorry about that, guys. I needed to make that go away. And so let's go ahead and solve this by eliminating. Looking here at these equations, 2x and negative 2x. If I have 2 and negative 2. What operation can I do between 2 and negative 2 that will make it equal 0? Well, we know that 2 plus negative 2 equals 0. So because this variable has the same coefficient, I want to add these two equations. I found that out here. I want to add these two equations, and then this right here will eliminate it. This 2x and negative 2x, the x's will be eliminated. So in doing that, I would just add all the parts of this. So 2x plus negative 2x just equals 0. 3y plus 5y gave me 8y. I'm going to write a big add sign over there because we're adding. 11 plus 13 equals 24. So now I've eliminated my x's. I have this new equation, 8y equals 24. Well, if I solve for y, I'm going to get that y equals 3. Next, I can use this in one of these equations, either one it'll work for, and I can figure out what x equals if y equals 3. So I would say 2x plus 3 times 3 equals 11. I put a 3 in for y. 2x plus 9 equals 11. Subtract 9 on both sides, and I would get 2x equals 2, or x equals 1. So I got the solution for this 1, 3. Checking my work, if I put a 1 in for x and a 3 in for y, I'd get 2 plus 9, which does equal 11. Works for this one. If I put a 1 in for x and a 3 in for y, I would get negative 2 plus 15, which does equal 13. So I'm happy. It worked for both of them. Let's try another one. 4x plus 3y equals 2, and 5x plus 3y equals negative 2. So if I look here, my y's have the same coefficient. So they're going to be the easiest things to eliminate, these y's. And so I have 3 and 3 as the coefficient. Well, the easiest way to eliminate that is by subtracting. 3 minus 3 is what will give me 0. So I want to subtract all parts of these equations. Oops, sorry about that. So going here, I'm going to subtract them. 4x minus 5x will give me a negative 1x. 3y minus 3y will give me 0. And 2 minus negative 2 would give me a positive 4. So I subtracted all parts. So from that, I'm going to get a divide by negative 1, divide by negative 1, x equals negative 4. Now I'll put that into one of my top equations, and I'd get 4 times negative 4 plus 3y equals 2. Negative 16 plus 3y equals 2. 3y equals 18, so y equals 6. So I get the point negative 4, 6. If I check that real quick, in my first equation I would get 16 plus 20 plus 18, which does negative 16 plus 18, which equals positive 2. In my second equation I would get negative 20 plus 18, which equals negative 2. So it works for both these equations. So negative 4, 6 is in fact my solution. The next one, so all of them so far, my variables have lined up. This one, my variables don't. I need my x and my y to be on the same side and my x's to come first. So if I rearrange this, so my x and y are on the same side and x comes first, I would subtract 3x from both sides. And that would be like saying negative 3x plus 4y equals 14. So my systems of equations is 8x minus 4y equals negative 4, negative 3x plus 4y equals 14. So looking here, it looks like my y's are going to cancel. And they're going to cancel by addition because negative 4 plus 4 is what equals 0. So we're going to add these parts together. 8x plus negative 3x is going to give me 5x. Negative 4 plus 14 is going to give me 10. So I get 5x equals 10. Divide by 5. X equals 2. Next, I'll put that into one of my other equations and solve for y. I'm going to actually put it into this original equation I got here, and I'd have 4y equals 3 times 2 plus 14. 4y equals, forgot my y, equals 6 plus 14. 4y equals 20, so y equals 5. So I have my solution 2, 5. If I put that into both equations, I'd get 16 minus 20. That does equal negative 4. My second one, I would get 20. 20 equals 6 plus 14. 6 plus 14 is 20, so it works for both of them. So my solution is in fact 2x, 2, 5. All right. All right. Another one. I want my x's and y's to line up. I'm going to, in this time, solve this one for my y part. And so, if I just want y on one side and everything else on the other side, I'd get 4y equals negative 3x minus 6. I just went ahead and subtracted 3x from both sides. And my second line was 2y equals positive 3x plus 6. So negative 3x and positive 3x would eliminate by addition. I'm going to add these two together. So I get 4y plus 2y equals 6y equals negative 6 plus 6 equals 0. So y equals 0. If I put that into this equation here, I would get 0 equals 3x plus 6. Subtract 6. Negative 6 equals 3x. So x equals negative 2. So I have the point negative 2 comma 0. Let's see if that works. Let's see, 3 times negative 2 is negative 6, plus 0 equals negative 6, so it works for the first equation. For the second equation, 0 equals 3 times negative 2 is negative 6, so negative 6 plus 6 is in fact 0. It works for both, so my solution is negative 2 comma 0. Oh man, we have another one. Alright, so this one I'm going to get this top equation to be in the same form as the bottom equation. So I would have, if I subtract 2x from both sides, 5y equals negative 2x plus 12. I'm just going to write that right underneath here so that it lines up for me. Negative 2x plus 12. So 5y and 5y, they're going to eliminate through subtraction because they have the same sign. So if we subtract 5y minus 5y is going to give me 0 equals 4x minus negative 2x would actually give me plus 2x. So 4x plus 2x is 6x. And 6 minus 12 is going to give me negative 6. Go ahead and solve for x. And you get 1 equals x. Put that into, we'll put it into this equation right here. It's a little easy. 5y equals negative 2 times 1 plus 12. So 5y equals 10. Y equals 2. So we get the point 1 comma 2. Let's check it. 2 plus 10 does equal 12. It works. 10, does 10 equal 4 plus 6? 4 plus 6 equals 10, so 10 equals 10. It works for both of them. So, let's talk about a real-world application. I know you guys love, if we talk about the business center here. So, a business center charges a flat fee to send faxes plus a fee per page. You send one fax with 4 pages for $5.36. And another fax with 7 pages for $7.88. Find the flat fee and the cost per page to send a fax. Okay, so for the first equation, we're going to send 4 pages, and we're going to let our cost per page equal x and our flat fee equal y. So we're going to spend 4 pages, so 4 times the cost per page, plus my flat fee, which would be y, and that first 4 pages cost me $5.36. The second one was 7 pages, so we'd have 7x. Still, I only have to pay my flat rate, and that cost me $7.88. So I am going to subtract these two because my y's can eliminate, my flat rate can eliminate if I subtract. And subtracting them, I would get 4x minus 7x, which equals negative 3x, equals, my y's canceled, 5.36 minus 7.88 is going to be equal negative 2.52. All right, so we'll divide by negative 3, and 2.52 divided by negative 3. This is where I would normally be asking you guys to pull out your calculator. You would get x equals 0.84. All right, so now we have our cost per page. If I put that into this first equation, 0 times 84 cents plus y is going to give me my $5.36. I ran out of room on the page, but you knew it was there. So 4 times 0.84 is 3.36 plus y equals 5.36. So when I subtract my 3.36, I get that my flat rate y equals $2. So my flat rate was $2, and my cost per page is $0.84. And that would be my solution. Let's head on back to the kayaking. All right, so jumping back to this kayaking example real quick. During a kayaking trip, a kayaker travels 12 miles upstream against the current and 12 miles downstream with the current. The speed of the current remained the constant the whole trip. We want to find the average speed of the kayak in still water and the speed of the current. So we want to find how fast was the kayaker actually kayaking, and then how fast was this current that the kayaker was in. So first we need to figure out, well, if they're going 12 miles upstream and it takes them 3 hours, using distance equals rate times time. So this is for my upstream. We're going 12 miles. We don't know what our rate is, but we know we go 3 hours. So our rate is 4 miles per hour. I should put the mph, sorry. For going upstream. And going downstream, we're going 12 miles still. Rate time is 2 hours. Oh, so wow, I'm going a lot faster. I'm going 6 miles per hour when I'm going downstream. So now we have these two equations. These are our totals. So in this upstream, against the current, you're traveling at 4 miles per hour. So my time in still water, or my rate in still water, I'm going to say is x. And the current, I'm going to make y. So going upstream, I'm going against the current. So I'd have x minus y equals my rate upstream, which would be 4. Going downstream, I'm with the current. The currents help me, so it would be x plus y equals 6. So on another page, we're going to solve this system. So we have x minus y equals 4, x plus y equals 6. I'm going to add these, so I get 2x equals 10, x equals 5. So I can figure out if x equals 5, 5 minus y equals 4, y equals 1. So my speed in still water is 5 miles per hour. The current speed is 1 mile per hour. So when I'm going upstream, the current's pushing against me 1 mile per hour. When I'm going downstream, the current's pushing with me at 1 mile per hour. No matter what, I am paddling at 5 miles per hour. So that's it for tonight.